So I want to take just a few minutes and talk to you about dividing and simplifying radical expressions. This is part of a series we're doing on radical expressions. I've got another video on adding and subtracting. I'm going to be working on a video on multiplying. But today our emphasis is on dividing and simplifying radical expressions. I always try and begin with a fairly simple illustration that teaches us a principle that we're going to use all the way through. The first example that I have is the square root of 100 over 4. Hopefully this is not overly complex for you, and hopefully you realize that order of operations says that you do whatever's under the radical or inside your grouping symbol first. This one happens to be 100 divided by 4, which is 25, followed by your square root, which is 5. I have a second example here that says the square root of 100 divided by the square root of 4. Notice that in this case, when we're talking about order of operations, the grouping symbol that's in effect is this division bar. So I need to do what's above the division bar first, what's below the division bar second, and then divide last. The square root of 100 is 10, and the square root of 4 is 2. 10 divided by 2 is 5. I'm going to pause there and hope that you're noticing something as we do this. Hold that thought in your head for just a second as we go to the next example. The square root of 144 over 36 and the square root of 144 divided by the square root of 36. You may want to pause the video and do this on your own. I, however, am going to keep going. 144 divided by 36 gives you 4. We do what's under the radical first. Square root of 4 is 2. Notice the second example, the square root of 144 divided by the square root of 36. The grouping symbol is that long division bar. So I do what's on top first. I do what's on bottom second. I divide last. And once again, I'm going to wait for just a moment so that you can see if there's a pattern here. Hopefully you've noticed that in both example 1 and example 2, regardless of which problem we're doing, we get the same answer. That's because of a mathematical principle known as the division property for radicals, which essentially says if I square root a fraction, I'm going to get the same result as if I were to square root the numerator and the denominator. For us in math, it's very helpful for us to be able to switch back and forth between those two forms, because certain problems are going to be easier to solve in one form and others are going to be easier to solve in another form. Let's do some that are a little more complex. If I wanted to do the square root of 36/25, I can either think about what times itself equals 36/25, or I can think about it in pieces. The square root of 36 is 6. The square root of 25 is 5. Both of these will give me the same answer. 6/5 times 6/5 is 36 over 25. If I have the square root of 12 over 75, my first instinct is to simplify that fraction. This is 4 over 25. I can either ask myself, what times itself equals 4/25, or I can look at it in pieces. The square root of 4 is 2, the square root of 25 is 5. 2/5 times 2/5 does equal 12/75. I'd recommend pausing the video at this point and trying C on your own. When you restart, you'll notice that I kept going. The square root of 18 over 32, I'm going to simplify that fraction first. This is 9 over 16. I can either ask what times itself equals 9/16, or I can split it into two radicals. Square root of 9 is 3. Square root of 16 is 4. This one's a little easier. Square root of 27 over 3. I'm going to simplify that into a 9. That one worked out pretty nicely. Sometimes the problem you're given is already going to have a numerator and a denominator that are both radicals. In this case, we might benefit from writing it the other way. Instead of having a radical on each piece, take the radical and put it over the whole thing. In this case, that's helpful because even though the square root of 125 is irrational and the square root of 5 is irrational, if I write it as a fraction, that fraction actually simplifies to a 25, which gives me a rational number. Notice in ABC, it benefited me to split it into pieces. But in E, it benefited me to take those pieces and put them together. We want to get good at seeing it both ways and then deciding which of those is most beneficial for us. I like this one. 30a to the third is a really funky irrational expression. 6a squared is an irrational expression. But I can put those together, simplify that fraction. 30 over 6 is 5. A cubed over a squared is a. And I can use that as my answer. Here again, I would probably pause the video. When you restart it, you'll notice that I kept going. If I put them together and simplify, 40 over 10 is 4. B to the fifth over b squared is b to the third. From there, I can square root the pieces. This is the square root of 4, the square root of b squared, and the square root of b, which makes 2b radical b. Notice I did do that last part fairly quickly. That's because by the time you reach this video, I'm operating under the assumption you already know how to square root monomial expressions. I think I'm going to go ahead and pause the video here and do a part 2. Make sure you check that out because in part 2 we're going to solve some problems that have radicals in the denominator that do not go away.